Hello, welcome to another session in mathematics. In this session, we'll be looking at matrix. Okay? But before that, let us take a review of our previous lesson. Welcome back. Today, our focus will be on application of matrices to solving simultaneous equation. In our last class, we talked about inverse method. Today, we'll be looking at what we call Cramer's rule. Okay, so let us quickly go to what we have for today. Cramer's rule. A Cramer's rule, if we have two simultaneous equations to be a1x plus b1y equal to k1, and then we'll have a2x plus b2y equal to k2. All we need to do is to form the matrix, which we all know how to do. We have a1, b1, a2, b2, and then we have our x and what, y, and that's equal to k1 and what, k2. Okay, and then to solve for x, we then replace the first column by the values of the constant on the right hand side of the equation. Okay, so to solve for x, we replace this by the constant on the right hand side. Then to solve for y, we replace this by the constant on the right hand side, and then we'll find their determinant, and then we divide and get our answer to get the values of x and y. So let us take some examples to explain that the more. We are given x plus 2y equals 4 and 3x minus y equals 5. The first thing to do is to form the matrix. Okay, this is our a1 and the quotient is 1. This is 3, this is 2, and this is minus 1. Remember, we are dealing with what? X and what? Y. Is that correct? And then we'll have this to be equal to 4 and 5. So, having formed this now, to get the value of x then will be equal to, I said you should replace the first column by the number on the right hand side. So we then have 4, 5, 2 and what, minus 1. Okay, and then for y, we then have this replace the second column, which will give us 1, 3, and then 4, 5. Then after this, the next thing to do is to find the determinant of these new matrices. To find the determinant. You know how to do that, right? So determinant of x would then be equal to 4 times minus 1, which will give us what? Minus 4, then minus 5 times 2, which is 10, minus 10, and that will give us minus what? 14. For this, we'll have 1 times 5, which will give us 5, and then 4 times 3, which will give us what? 12. So have minus 12. 5 minus 12 will give us minus 7. Is that correct? Okay, so we've gotten the determinant of the two new what? Matrices. We then get the determinant of the original matrix, which is 1, 2, 3 and minus 1. 3 minus 1. That will give us 1 times minus 1 minus 1. 3 times 5, that is what? 6. So we have minus 6, and that will give us minus 7. Minus 6 minus 1 will give us minus 7. Okay, So our x then is equal to the value of the determinant of the new matrix divided by the value of the determinant of what? The original matrix. So x is equal to minus 14 divided by minus 7. Minus 14 over minus 7. And that will give us what? 2. Then to get the value of y is equal to the value of the determinant of the new matrix, y, divided by the determinant of the original matrix. So we have minus 7 over minus 7. And that will give us what? 1 as our answer. So x is equal to 2 and y is equal to 1. If you solve this using inverse rule, you will still get the same values for x and y. So let's take a 3 by 3 matrix, an example on 3 by 3 matrix. Okay, the first example here, he said we should solve this equation is here using Cramer's rule. X plus 5y minus z equal to 8, 3x minus 2y plus 4z equal to 0, 2x plus y minus 2z equal to 7. Okay, like I told us, the first thing we do is to form the matrix. By forming the matrix, we'll have coefficient of x here is 1, coefficient of y is 5, coefficient of z is minus 1, coefficient of x here is 3, coefficient of y here is minus 2, coefficient of z is 4, coefficient of x is 2, coefficient of y is 1, and coefficient of z is minus 2. Okay, the variables we are dealing with are x, y, and z. Okay, and we have their results to be equal to 807. So to get the value of x, we do what? We replace the first row with the constant we have on the right hand side of this equation. Therefore we have x to be equal to a new matrix. We have 807. Then remember we remove this, and then we have 5 minus 2 1 minus 1 4 and minus 2. Okay, at the same time we have to find what? The determinant of x. Okay, we'll find the determinant of x. How do we do that? For 8 we have this and this cancelled, so we have minus 2 times minus 2 to give us 4, minus 4 times 1 4, then minus, remember this is plus minus and plus, minus 5 into this and this will be cancelled. So we have such that we'll have 0 times minus 2, which is 0, minus 4 times 7. 4 times 7 will give us what? 28. Okay, and then we'll have plus minus 1, so that will give us minus 1 into this is cancelled and this is cancelled, right? So we have 0 times 1, which is 0, minus 2 times 7 will give us minus 14. Therefore this becomes what? Plus. So we have 8 into 0 minus 5 into minus 28 minus 1 into 14. 8 times 0 is 0, minus 5 times 28 will give us 140, and then minus 1 times 14 will give us minus 14. 140 minus 14 will give us 126, and that's the value of what? The value of x. Okay, that's the determinant of x. So let's form y now. For matrix y means we'll replace the second column by the answer we have here on the right hand side. So therefore we have 1 3 2, then we'll replace it with what? 807. So we have 807, and then our third column, which is minus 1 4 and minus 2, minus 1 4 and minus 2. We also find what? The determinant of y, and that will give us, the first one here is 1 into, cancel this and this, we have 0 times minus 2 to be 0, minus 7 times 4, which is what? 28. Is that correct? Then the next thing here is minus 8 plus minus plus. So have minus 8 into this, and this is cancelled. So have 3 times minus 2, which is minus 6. 4 times 2, that will give us minus 8. Is that correct? Then the last one we have here is minus 1 into, cancel this and this. We have 3 times 7, which will give us what? 21. Minus 0 times 2 is 0. We have 1 into minus 28, minus 8 into minus 8 minus 6 will give us minus 14, and then minus 1 into 21. This will give us 1 times minus 28 will give us minus 28. Then minus 8 times 14. What do we have? We have plus 112, then minus 21. So 112 minus 28, and then minus 21 will give us 63. And that's the determinant of what? Y. Okay, we then solve for Z, for the matrix of Z. Okay, that is to replace the last column with what? This value here. So we'll have 1, 3, 2, and we'll have 5 minus 2, 1, 5 minus 2, 1, and then we'll have this to be 807. 807. Okay, the determinant to then be 1 into this, and this is gone. Minus 2 times 7 is minus 14, minus 0 times 1 is 0. Then minus 5 into this, and this will go. 3 times 7 is what? 21, minus 0 times 2 is what? Is 0. Right? And then we have plus 8 into, cancel this and cancel this. We have okay, this and this. We have 3 minus 2 and what? 2 and 1. So 3 times 1 will give us 3. Minus 2 times 2 will give us what? Minus 4. Right? So we have 1 into minus 14, minus 5 into 21, plus 8 into this is 7. Right? 1 times minus 14 is minus 14, and then minus 5 times 21, minus 5 times 21 will give us minus 105. Then 8 times 7, 56. Then 56 minus 105 and minus 14 will give us minus 63. So we've gotten the determinant of x to be 126. Remember, that is it here. And the determinant of y to be 63. Determinant of y is 63, and then determinant of z is equal to what? Minus 63. So what next are we looking for? We then solve for what? The determinant of the original matrix, and the original matrix is given as, let's go back, 1, 3, 2, 1, 3 and 2, 5 minus 2 and 1, 5 minus 2 and 1, and then minus 1, 4 and minus 2, minus 1, 4 and minus 2. Okay, then to solve for the determinant of this, we have 1 into this, will cancel this. Minus 2 times minus 2 is 4. 4 times 4 is minus 4. Then minus 5 into this, and this will go. 3 times minus 2 is minus 6. 4 times 2 is 8. Minus 1 into this, and this will go. 3 times 1 is 3. Minus 2 times 2 is minus 4. So have minus 4. And that will give us 1 into 0. Minus 5 into minus 6 minus 8 will give us what? Minus 14. Minus 14. Then minus 1 into 3 plus 4, which is what? 7. So 1 times 0 is 0. Plus, we have minus 5 times minus 14, and that will give us a positive number, right? We have 70 and then minus 7, which is what? 63. So the determinant of the original matrix is 63. We then divide everything here by 63. So 126 divided by 63, what do we have? We have what? 2. 63 by 63 is 1. Minus 63 divided by 63 is minus 1. So the value of x is 2, the value of y is 1, and the value of z is what? Minus 1. And that's the solution to the problem here on the screen. So we'll stop here today. Thank you for being part of today's class. To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with Cramer's rule of matrix. I will stop here. Okay, so do well to use the lesson note on the platform for better information on what we've just discussed, and feel free to leave your questions or comment on the comment section. Till we meet again, stay safe. Bye.